Good day and good evening, everyone. My name is Leonard Lee. I'm the founder and managing director of NextCurve, a research advisory firm working with some of the leading technology companies to help shape our digital future. And we focus on emerging markets forming along the leading edge of technology and the ICT industry. And today, I'm very honored to have been invited by ZEDEDA, not ZEDEDA. Yes, ZEDEDA, to moderate what promises to be the discussion and debate on two of the hottest topics buzzing today, 5G and edge computing. And in this panel discussion, we will delve into the implications of 5G on edge computing and the future of the ICT industry. And so now I have a distinguished panel of industry leaders, and you guys are leaders, whether you like it or not, joining me representing different stakeholder groups in the 5G and edge computing game. Gentlemen, I don't want to steal your thunders by doing a hack job with your introduction. So please take a brief moment to introduce yourselves. Should we go by market cap? Should we go by revenue? Who wants to go first?
I think Ram's going first.
Is he?
Okay,
I think it's
that's
Kevin,
fine. I'm being
but...
volunteered here. Okay, that's fine. Okay, thanks a lot, everyone. Nice to be able to meet you all virtually. My name is Ramkumar Venketaramani. So I'm Senior Director for Solutions Management here in Service Provider and Edge Business Unit at VMware. I've been with the telco industry for the past 20-25 years, been through the rung and now creating 5G private connectivity solutions and mobile edge computing solutions at VMware. Rob, do you want to go next?
Thank you for passing the baton. So Rob Tiffany, I'm a vice president and head of IoT strategy at Ericsson. We're one of those companies that actually makes 5G, which is kind of convenient, isn't it, for this session? And yes, my background is mostly in IoT and edge computing at Microsoft and Hitachi, mostly industrial stuff. And I know Leonard way too well. And so be careful with that guy. I'm going to pass it along to Sander.
Thank you, Rob. So I'm working for Siemens. I'm Director of Industrial Wireless Communication, focusing on industrial here. So I've been working with wireless communication for over 15 years. And as Rob is doing with his fellow colleagues, we also work on something with 5G, mainly end devices, but in the future also private networks. And probably that's the reason why I'm here today. And then we do have some edge stuff as well in our portfolio. Let's see if we can touch up on that later. And then Kevin, over to you.
Thank you. I think if we went by market cap and revenue, I think I probably would have been at the beginning or the end. So I'll go last.
Yeah.
In which of the two you would have been the first?
It depends if we went highest to lowest or lowest to highest.
Oh, okay. I thought revenue or market cap was okay.
I should have made that clear.
Kevin Shatzkamer, I've been in the wireless and mobile industry for the better part of 20 some odd years, spanning a number of different organizations, including Cisco and Dell Technologies for the last several years. I've been leading digital transformation with our largest, most strategic telecom partners at Google Cloud, but also, of course, leveraging the broader capabilities of Google. We have a number of technologies in wireless, ranging from handsets, certainly, but also are very invested in taking the cloud further out to the edge and expanding for our application developer ecosystem the capabilities that edge computing affords them in terms of latency and bandwidth and improved experiences in both the consumer and enterprise side.
Wonderful. Okay, so now that we have that out of the way, are you gentlemen ready to rumble? Are you ready to do this?
Yes, I think it's going to be Google Android versus Windows Mobile.
Yeah. All right. Well, okay. So, hey, let's start off then with edge computing. Okay, since we're going to be talking about edge computing and 5G, let's start with edge computing. And you know, there's many folks who say that edge computing has been here for a long time. They've been doing edge computing, blah blah blah. Right. One of the things I want to ask you guys is, what is the big deal? Why has edge computing all of a sudden become the thing? And I'm interested in understanding from you gentlemen, what's particularly interesting about edge computing from your perspective in the areas that you guys work in. Who wants to go first? Let's just have a conversation, guys.
Sure.
What's the big deal?
I'm happy to kick it off, right? Because I think those of us who've been in networking a very long time have known that we've solved law of large numbers problems with decentralization and building technologies at the edge for the entire history of the internet, right? Anytime we have too much of anything, we've decentralized and we've built technologies out at the edge, right? We've distributed routing tables, we've distributed DNS, we've built content delivery networks, keep on going down the list. And I think as we've moved more and more of applications and workloads towards the cloud, right? That's why Google Cloud's here. What we're starting to realize is that there's downsides to big centralized massive data centers as well. Call it data, call it latency, call it variance, call it jitter, call it difficulty in offering quality of service, call it data residency requirements, et cetera. So we see this trend of, as applications become more real time, as they become more data intensive, as they become more interactive, decentralization is the name of the game. I won't necessarily always call it edge, but the need to move from big centralized locations towards more decentralized locations is just the way we handle scale.
Yeah, that makes
sense.
Just to piggyback on what Kevin just said, right? So, the distributed edge computing or distributed computing, like let's say if you take an industry like retail industry, for example, there has always been some sort of computing happening in the store itself, right? So that is nothing new to it. But the point that is new right now with the edge computing paradigm is what we call as a cloud computing continuum, right? So the world has moved away from a centralized data center to a public cloud only architecture to a multi-cloud architecture, right? Being able to leverage the right cloud for the right workloads at the right point in time, right? So that's really the mantra that most of the customers that at least that we have been talking to, be it a retail industry or be it an industry 4.0 customer, or it could be even government in certain cases, they're all looking at this multi-cloud computing continuum. And that's what really makes the edge computing become really important right now, because now you can no longer look at your nano data center in your local premise as an isolated entity. It is a part of the overall puzzle, right? So you need to manage it and operate it in the same way like you would like to manage and operate your private cloud or your public workloads in the public cloud. So that's the key distinctive element that is introduced by edge computing.
You know, sometimes it's just plain old pragmatic stuff. Like long before customers read any analyst reports to tell them what to think. So I Leonard's heard this story. I go back to when I was at Microsoft and we were building Azure, and then we were building Azure IoT. And so I absolutely remember going and spending times with people over at Boeing and telling them all about this cool new Azure IoT stuff we had. This is a long time ago, and streaming analytics and ML and all that. And you know what they said? They're like, wow, that is awesome. Show me the version of that runs right here on my factory floor. And we're like, and that's when you start tap dancing, right? And then, but the reasoning was just really pragmatic. It was, some of it was about data sovereignty and security. Most times, as Leonard and I talk about, economics usually trumps everything every time. And it's not because of some cool architecture they're trying to model after. It is literally dollars and cents. And so these guys are like, I don't have the time to send data to your distant cloud data center to have it munch on the data for a while and then give me an answer to the question. I need it like that. The other thing was it's expensive. We have giant machines that are spitting out terabytes of data per hour to build aircraft. And it's really expensive for me to ship that data over expensive bandwidth to your data center. And so, it's just, sometimes it's just really common sense, pragmatic stuff. And it's like, where's the version of that happens right here? And that's kind of when you scratch your head, and that's when you started thinking, at least in terms of IoT, you started hearing terms back then. Cisco was talking about fog computing. and then you started hearing people say fog and then edge and whatever. But a lot of times it's just, let's just get real. We're just trying to solve a problem, and here are the constraints, and it's just a location. So that's kind of where I kind of got introduced to it.
Yeah. So Rob, are you saying that this is all just about, being practical and keeping it real?
Sometimes you just need to be practical and keep it real.
Okay.
Sometimes.
All right, so that's always good. All right. So we got to pass the baton over to Sanders. And please do not talk about beer. We're not here to talk about beer, Sanders.
No.
Okay.
I tried to
We want
stay
your
away
thoughts
from
on
it.
edge computing. Okay.
It's
Good,
after
good.
9 o'clock here in the evening, but So we have we are supporting, of course, with edge computing many beer manufacturers, beer breweries in the world already. No beers, you said. Sorry, just kidding. You got that going for you, Leonard.
Yeah.
I know. I asked for it.
Yeah, I know. So, but let's get a little bit more serious. I think what you've been doing the last years is something which is about to start, or just has recently started, really in the industrial space. So we never adopted technology before it's already proven somewhere else. Because when we talk about latencies, we don't talk about the delay you have when you receive your email. When we talk about delays, we talk about two robots interacting with each other. And if two robots work together, the only way they can work together is by communicating over a data network. Because except for in Hollywood movies, I've never seen robots talking to each other by phone or by voice. So they really need this low latency. And this is where actually the combination of an edge and a cloud, so a decentralized and a centralized approach come together. And optimizing the way they work. For example, if you have AGV running throughout a facility, you want to have as much intelligence on board of the AGV so it can interact on its own when it loses its connection for whatever reason. Think about safety. People running around on the same shop floor. You don't want a robot carrying a car or a part of a car running over your foot. That hurts, even in steel toe shoes. And that's where I believe this is something when it's really proven, we can start rolling it out. And one of the big benefits of edge computing, from my point of view, will really be leveraging that what we already have on the vehicles, creating an added value, and having the possibility to offload only the necessary data to a cloud-based on-premise or off-premise system.
Yeah, Sander, just kind of picking up on your thread on the latency conversation, and Rob, maybe building on your comments on the dollars and cents, right? My experience is that there's not a single engineer in the world, when you offer them lower latency, that is going to say, no, I don't want that, right? But the reality is that there's a selective set of use cases where that lower latency is actually necessary. And it's really important to stay focused on those cases where it's monetizable, where there's going to be spend against that reduced latency or improved performance. And I kind of bucket that into two worlds. One is where the speed to decision making and control systems, call it high-speed manufacturing or conveyors, and those control systems loops are so important. And then the other is where operational safety decisions are time sensitive, right? Maybe autonomous vehicles is an example of that. And of course, there's going to be gaming use cases that materialize within here as well. But generally speaking, what we're seeing from the enterprise is those two scenarios where they're actually not just willing to explore edge computing, but invest into it.
Yeah.
Great. Well, you know what, gentlemen, I'm surprised no one brought up reliability, but I'll give you a chance to speak on it as we move on to our next question here, which is actually, it's the other topic. It's the other hand that we're discussing in this panel, which is 5G. So how do you feel that 5G will change edge computing as we know it now, and how it will influence things going forward? And what sort of value enablement and possibilities do you see it bringing to your clients as they're looking at edge computing possibilities themselves? Anyone want to go first? That was a beautiful question, right? I know it was awesome, Rob.
Yeah.
Totally
we can put it in the chat for you. I remembered it. So no, I think so I'm fully focused on industrial use cases. And from my point of view, when we talk about having a public network, I do not see a real game changer between 5G and 4G today. because we still have to work with the public network, and we talk also about data privacy. So many of our customers want to keep their information private for certain reasons. For example, if you, how much data do you believe? So what kind of car you driving, Leonard?
Oh, me? I
Yeah.
have a Tesla Model 3.
So great example. How much software do you think is on that car?
A lot.
A lot.
Is
I
it
don't
like?
know. I mean, what are the options I have? Little, medium, a lot?
Yeah.
I'll
So
pick a
so
lot.
let's say a gig, 10 gig,
Yeah.
100 gig.
Yeah.
Where do you think it is at right now?
Geez, 100 gig. I'll just go for the top.
Yeah, so that's years
No.
down the road, but it's
Okay.
about 10 gig at the moment. That's what you can assume.
Okay.
So when do
Alright.
you think this data is loaded on the car right now?
When is it loaded on the data?
Yeah,
I mean,
so
on
because the car
when it's
isn't
manufac-
born like we do and learn,
Yeah,
the software
right,
needs to be installed onto the car. And so if we look at this from a network perspective, today it works like this: to produce the car is done, it's being charged, the initial charge, and at that moment someone plugs in a cable and loads the software on the car. Or in a modern Tesla factory, they probably use wireless LAN to do that. So in the future, this could be moving to, for example, 5G, but they are actually loading intellectual property inside the car. And that is something they want to keep for themselves. So that's where private networking comes into the game. And especially in an IoT environment, private 5G networks will be really a game changer, where you can do all these things in your own environment, where you control the whole thing, and you're able to maybe in the future, already during the production of the car, start loading software on your car. And then all of a sudden, this loading of 10 gig, or in a couple of years, 20 gigs of data, is not taking minutes after producing the car anymore. It's already done when the car rolls off the belt. So these are changes we will see happening when you talk about 5G, and this is also something where we could talk about adding edge computing to the manufacturing world as well. But the important thing is you really need to distinguish between private 5G use cases or private network use cases and public network use cases. And then when we talk about, for example, then the other side of the spectrum, a wastewater treatment plant, they're in the middle of nowhere, and they typically are the ones utilizing clouds for analytics, and you can imagine what they analyze in water treatment plants in the future. And this could actually be a big benefit of using a public network combined with a cloud, with an AI, throwing in another technology, and then utilizing edge on site, for example.
Yeah, so just to piggyback on what Sander was saying, right? So if you just take a look at the retail industry, I think Sander covered the industrial use case fairly well. But if you look at the retail use case, particularly online shopping, one of the key things or key requirements that they have is being able to do the packaging in an efficient manner, right? So we have talked to a couple of retail warehouse customers, and one of the things that they do is they have these AGVs which are roaming around in the warehouse, picking up grocery items from various bins and then taking it to a particular place and dropping it off in the bag, which is going to be packed for a particular customer. Now, the only connectivity that will work for this kind of a model is a wireless connectivity, and 5G really enables this kind of a use case, because it has not only the EMBB capabilities, but it also has a low latency and the large number of device things. Now, some other big online shopping company, they use drones for the same application. If they're not looking at AGVs, now they're going vertical as well with the drone-based packaging. So 5G, in essence, I think it's going to completely open up the user experience in many different directions that we are completely unfamiliar of right now. Just like how mobile networks did a while ago, this is going to be a major technology changer in the user experience, I feel.
Absolutely. I got started probably with the edge stuff, probably more in manufacturing as well. Building a Lumato, I was living in Japanese factories as we designed that to work with control systems. It also was very edgy. We got it running on bullet trains too. But what I found interesting going from Hitachi to Ericsson, which is like apples and oranges, is seeing telecom people begin to talk about the edge and somehow associating it with 5G. And I was like, what are you guys talking about? We've already got this stuff and there's reasons for it. And it's actually unrelated to your wireless networks. It's really just to be close to the source of the data, right? And having fast latency. But as time has gone by, you started hearing these new terms like mobile edge computing or multi-channel edge computing. I've seen, MEC. And as we're rolling out 5G and putting compute in different locations, the telecom folks started thinking, well, gosh, maybe that should be a complementary thing with 5G. Maybe I'll put edge compute at the edge of the cellular network. I might put it in a base station at the bottom of a cell tower. All the mobile operators have hundreds of hidden data centers in metro areas of cities all over the world, where your data, it's going from your phone or your car or whatever to the cell tower and down and backhaul and goes through their networks and their data centers long before it goes out to the open internet to go to your final destination. And so there's this notion of putting edge compute in those locations as well. And it's funny because I'll hear the telecom people call what I thought was the normal edge, like by a machine in the factory. They're like, what is that? That's the far edge or the deep edge. And I'm like, no, dude, it's the edge. Yours is the new edge. You just made that up yesterday. And so the good stuff about it, though, is you're going to have all these edges. It's a multi-edge world now. And you're going to have it at cell towers and stuff like that. And the benefits, obviously, it's all about lower latency, of course, in a big way, oftentimes. It's also going to reduce clogging up that telecom network, right? If you get the answer to your question shortly after you hit your cell tower and go to a nearby data center rather than the hub and spoke of clogging all the public clouds, then there's not going to be as much congestion on the network. So that's going to be a positive deal. But as our good friend Jason Shepard would like to probably comment if he was talking here, was ZEDEDA, is edge computing, especially this telecom version of edge, MEC, it requires considerable orchestration to pull that off because it gets super complex. And that's all I've got to say right now.
Yeah, I would build on that, right? And I think there's a consistent theme here amongst everyone here, which is that edge solutions are going to find ways to benefit from 5G, but the solution space of edge is much larger than just the 5G access networks. But the same holds true as well, which is that while 5G will potentially be a big key enabler for edge solutions, 5G also has its own use cases that are not dependent on edge computing. Right. I think if we kind of think about the objectives of 5G and what 5G is bringing us, it's really predominantly focused on network performance. To Rob's point, it's bigger pipes, it's lower latency capabilities. The architecture itself lends itself well to decentralization and building the architectures in an edge fashion. And 5G alone will improve performance. And then when you couple it with technologies like network slicing, you actually can start offering SLOs and enforcing SLAs against that 5G network. And then when you start to think about 5G and how you intelligently place workloads by knowing the capabilities and integrating with the capabilities of that more performant, more visible, more decentralized access network, overall the system becomes more efficient.
Yes, all Kevin, the stuff that Kevin said. Yes.
Yeah, and you're making a great point there, and that there's an opportunity to make workloads network aware, right? So you're looking at a distributed computing model, and when you look at mobile edge computing, and I mean specifically mobile edge computing, knowing where to place workloads in the network edge or the access edge, that's important. So that's a great point, I think, that you've brought up, Kevin. So kudos. That's awesome.
Kudos to you.
Yeah.
Nice.
Yeah.
Yes.
Wonderful stuff.
Nice. I wish I had a mic to drop it.
Yeah. Just boom.
Just a virtual mic is fine.
Exactly.
Yeah. So, gentlemen, I want to ask this question: where do you think we are with 5G today? Okay. I'm asking this question because I will just give you a hint. We're still in early days as we look at industrial use cases and other enterprise use cases. The rollouts are still pretty early. And when you look at the 5G roadmap with release 16, we're still seeing a lot of these features now express themselves commercially and industrially, right? So where do you, I don't know if I just answered my own question. And if I did, I'm sorry.
We're just going to
I
move
really
right along,
apologize.
Leonard, to something else because
No, but I want to pick your brain. No, I didn't. Actually, I didn't. You might disagree with me. And if you disagree with me, wonderful. You just, share that Buddha knowledge with us.
Yeah. What if I'm not interested in your
where are
question and I want to talk about Sander's stuff instead?
we?
I
That's
thought
you meant the bears.
We'll
Yeah,
just start
October is right
to
around
start
the corner.
Clubhouse.
I just thought it was
Yeah.
more interesting to talk about this whole private 5G thing in factories and stuff like that. I mean, that's really cool, and it's something a lot of people aren't thinking about, right?
But I also think, Rob, they go a little bit hand in hand.
Oh,
That makes it interesting. So I think, Leonard, I agree with your statement. We are not that far along with 5G. The big problem is the mobile network operators all act like we already have 5G. So I'm in my business right now. I don't even have 3G or 4G. Oh, wait, by the way, they disabled 3G in Germany already. So I actually do not even have a lot of cell phone reception outside of my house. I live on the edge of a somewhat smaller village.
you live on the edge?
I live on the edge. Yeah, it's like coming to your point. You have a multi-edge world. Do you think mobile network operators think the Earth is flat?
Yes.
Yes.
Okay, that's already where it all starts
Yeah.
with reception.
Yeah.
They forgot to
solves a
calculate
lot of
in the curve.
It solves a lot of problems when the world is flat,
Yeah,
right?
Definitely. No hills in between, no curve. You have to
Absolutely.
We just solved that's how they go around it, or actually not around it. No, but without joking too much. So with 5G, we now have release 16 released since July 2020. Have you ever held a commercial device in your hand supporting any release 16 features? So everyone's putting its hands up, saying right now that must have been in your dreams. So, and then if we look at it from an industrial perspective, we are not even talking about seeing devices based on an ARC study before the end of 2022, because I'm not helped with a cell phone. Mine actually has 5G capabilities, but I'm not helped with a cell phone in the factory. I need a ruggedized hardware which supports industry features such as private networking. And those features are part of the Release 16 standard to be fully deployed in an open possible way. And then besides the fact that we need the technology to become available, we also need to get our hands on spectrum. That's the new gold. Because if you do not have spectrum access, you have a problem. And here in Germany, I was together with some colleagues, part of a working group within the industry to advocate for private spectrum for campus networks or industrial networks. So we were lucky enough to secure here 100 megahertz of spectrum in the C-band, 3.7 to 3.8 gigahertz. It's similar to what you use with Wi-Fi. And then we also got 800 megahertz as a possibility in the millimeter wave spectrum. So we are actually able here to run our own networks, and we as Siemens already have some tests going on with those networks, and we invite customers to test with us in Hanover, one of the biggest test beds in the world, where you can really live your 5G dreams way ahead of time. And so this is something which is important, and we need to do this in many, many more countries. So even in Europe, this is not all across the board. So we have countries doing a little bit of this, a little bit of that. Yeah. We need to make sure this is done standardized. CBRS is an interesting way in the US. In the UK, we have shared spectrum. In Finland, they have 20 megahertz. That's like, that is not even enough. So if you compare this, that is you need €1 to start your shopping cart, or $1 or whatever you put in there in the US. I think in the US they're free. But here you need to put €1 in because they don't trust us. But with 20 cents, 20 megahertz, you can't even get your shopping cart. It doesn't even work. And we only get 20 megahertz here of spectrum, so that's like nothing.
Maybe that's how we should measure spectrum, is how many shopping carts worth of spectrum do you have?
Yeah, that's actually... Yeah. And then you can fill them up. And then you can actually and then you can actually fill them up with...
Yeah. No, you're so right, though.
Yeah. Sander is making a very valid...
That there's a way to answer your question, and it just depends on the lens that you look at the problem from. If you're in marketing and advertising, you're at the top of your game right now, selling capabilities of 5G that haven't been introduced right now. If you're in telecom operations, you're frantically scrambling to try to deliver on what the marketing team has set expectations around. And if you're a consumer accessing a 5G device, you're looking at it and you're saying, it's really not better than what I have today. In many instances,
It's actually worse. It's actually worse.
Worse. Yes, exactly. Exactly.
No,
Rob,
exactly.
We've done testing.
like
We've
that
done
guy.
testing.
Oh.
We've done testing with our device. It runs 30% faster on a local 4G network and a 5G network, because what they actually do with the spectrum, they do dynamic spectrum sharing. And because there's not enough 5G users, they only allocate the limited amount of spectrum. And that's done. Rob, you need to talk to your colleagues, because you guys actually enable them to do this.
Yeah, I apologize in advance.
Yeah. It's
Spectrum sharing was a clever idea, though, and the average consumer has no idea why that's important. The problem is this is such an expensive game to be in, because what most consumers don't realize is spectrum is auctioned off by governments for tens of billions of dollars or euros, and so it's hard to even play in that game. You've got to have a lot of cash up front. And then the tough part, I know we just finished an auction over about 6 months ago over the holidays in the US. And I think Leonard, was it close to 100 billion or some insane amount of money that operators spent to buy, because they're buying new spectrum for 5G is what they're doing. A lot of people don't realize, they think, oh, I'm just going to use the spectrum I already have. And it doesn't work that way. And so you have to get more. And then, of course, what do the operators now need to do? I've got to monetize. Am I going to get a payback on this giant investment I just made on spectrum? Maybe.
and that's a good point, Rob. Huh?
Yeah.
Okay.
So that's
sorry.
the thing, right?
Well,
So
wait,
some
guys.
of the So that's a very valid point, right? So people are spending billions of dollars on the spectrum now. The question is, how are they going to monetize it? And if you look at what Sander was saying, right, the device ecosystem is a little bit lagging today, right? From a 5G standpoint, they are primarily at release 15, getting into release 16. Again, not a lot, nothing much is available on release 16. And then we have URLLC enhancements coming in release 17, and some more timing related enhancements coming in release 18 and so forth. So there is where we are in the 5G journey. I would say we are still in the beginning stages, right? So we have not even left the station. I mean, that's how I would probably characterize it. And to the spectrum point that Sander pointed out, very few countries are having private spectrum being granted by government, but the key element is how much of continuous spectrum is the government granting, right? So in order for us to enjoy the EMBB kind of use cases, you need at least 40 megahertz of continuous spectrum. Like 10 Cs and 20 is not going to suffice, right? But if you look at CBRS in US, majority of the spectrum bands that are allocated is 5, 10, and 20. I mean, there is a little bit of 30, 40, and 80, but there's not a lot of those available today. So there's a lot of things that need to happen in order for 5G to take off in a big way. So it's not just technological, but there is also, regulatory related issues that also needs to be addressed.
Okay, gentlemen, we have only about 5 minutes left, and I know that.
Really?
What?
Can you believe it? I know we're having so much
Can we
fun.
not skip another panel and just keep on going?
Let's just keep going.
Yeah, I don't know if we can.
Let's just keep going
in real time.
Who's
Yeah,
the for derailing the conversation and bringing us off topic. Who do we blame for that for only 5 minutes?
Always Rob.
No, it's Sander. It's Sander.
Yeah, him too.
Sorry,
Both of them.
Yeah.
So we have a question. Okay, one. I'm not going to pretend we have 100. We only have one. Okay. The question is, edge computing has not waited for 5G. How do operators plan to catch up? Which parts of their strategy to catch up are realistic given their track record? But I think a broader question here is, what is the opportunity and what's the play? What's the play for all the different folks who are chasing this 5G edge computing pot of gold, if there is even a pot of gold? So who wants to start off with that? Remember, we have 5 minutes.
Multiplayer video games. That's it.
And let them get their act together and offer what we actually need. We do not need contracts in a factory, for example. We need the ability to set up private networks, and they need to start offering their spectrum for reasonable fees. Because, for example, in Germany, what do you think an average factory costs? An average factory, about 150,000 square meters, and then someone can do the math in feet, I don't know that number, is about 5,000 to 6,000 euros for 10 years of spectrum fee. That's less than I pay for my cell phone contract in the country.
So Sander,
yeah.
So because of all this, do you expect private 5G to have a big fight on its hands with Wi-Fi 6?
So I think they go
Maybe?
hand in hand. We offer both. And I think because of the limitation of spectrum, you will have mission critical applications, which you want to do with dedicated spectrum, where you have control over yourself. And then there is a lot of applications which we've been doing for the last 15 years with devices like this, which is Wi-Fi 2 or something.
Yeah.
We can use the shared spectrum because they're not mission critical. They are not elementary to get your factory running, but they're still important enough to move data from left to right. So for me, it's definitely hand in hand.
I missed the memo that we were supposed to have props ready, Sander. You're way more efficient.
Oh man,
I'm Dutch living in German. I always need to. You brought a pool. That's right. Yeah.
Leonard, I'll kind of comment. Right. I think what we're seeing in edge computing is still very tip of the spear use cases. I wouldn't say that anyone's missed the opportunity to participate in edge computing at this given stage. Right, the industries in which we're discussing the role of edge computing, call it manufacturing, industrial automation, retail, autonomous vehicles, multiplayer gaming, etc. All of those industries are in the process of their own transformations and looking at how edge computing plays a role within those transformations. So I think we're still really early in the game. No one's missed an opportunity to participate.
Yeah, exactly.
So and so. I really want, I'm interested in your take here. So are you saying from a business model perspective or ecosystem model perspective, we're still in the beginning innings of figuring out how all the stuff is going to pan out? Is that what you're saying? Or do you see certain types of go-to-market models that you think are going to work as, because, right now we have telcos as well as cloud service providers such as Google Cloud, eyeing this opportunity, right? Do you see anything that's forming? What's your take on that?
Yeah, I think look, there's layers over layers over layers of ecosystems that are being built right now, right? I think there's growing recognition that there's no one single entity that will have a monopoly over the way edge computing falls out, and capabilities of lots of different organizations come into play. Right. There's application developers that are really good at what they do and envisioning what those new use cases are. There's developer ecosystems and APIs that are being built to enable those developers to be successful. There's platform companies that are participating to create an environment in which those application developers can go and innovate. There's network providers and 5G networks and CBRS providers and global systems integrators that are standing up the infrastructure upon which the devices and the applications will communicate with each other. And I think everyone's somewhat talking to everyone at the moment. And over time, we'll start to see those ecosystems converge a little bit.
Yeah, great. So, hey, Rob, we have a minute left. So 30 seconds for each of you. Who wants to go first? Your final thoughts.
Sure. One of the things I wanted to add to respond to Michael Dahlbeck over there is, from a carrier standpoint, another key use case that they are looking into is the federated edge computing use case. They have some standardization going on under the GSMA auspices over there. That's another angle that Telco is created for themselves to play in the new upcoming edge computing world. Rob, final thoughts.
My final thoughts are the analysts just finished telling us about all this stuff, and so we need to take time to invent use cases to need to force us to have to use this. So give us some breathing room first, and then we'll come up with something eventually.
Wonderful. I love that. And on that note, that's all the time we have. Unfortunately, we're running a little bit over. I'd like to thank our distinguished panel speakers and thank our audience for tuning in, and have a wonderful ZEDEDA. Okay. ZEDEDA Transform 2021 events. Did I get it right?
Now we need.
Okay. All right. Well, we'll catch you next time, and be safe and be healthy. Thank you so much.